I have texted John to see if that helps.
Yes, and I actually remember I have status, so I think I'll go ahead with status here in just a moment. There's John. Okay, so I'll go ahead and start right on time. We're missing G. It looks like it's recording, so we'll just go ahead. Welcome, this is an interim for IDR. I'm going to go through the administrivia and see if we can work through things. This is the note well. If I look at everyone in the list, I think that everyone has seen the note well before or helped modify it. So I'm trusting you know that you should reread it. Welcome, Russ. So the agenda bashing, I'm going to go through a chair's report and slides. That'll be the first minute. Then we're going to go through a car and CT section where I go through a progress report. The progress report is mostly, I finally finished the Forum 3 report, and then Jeff is going to answer questions or on procedures for BGP routes with color. This is the diffract. We thought we might have some more additions this morning, but they do not appear to be ready. So we'll have more of that at IETF 115. The next topic is John Scudder will be doing the entropy label. Excuse me, let me take a step back. The best chairs a while back when we swapped to 3 chairs, which will tell you how long ago, mentioned that it would be really good to provide us more guidelines on the BGP next stop. So if we hit the draft Scudder IDF entry fee level, we had a useful discussion. Maybe John and Bruno have come to some merge solution that is good. Kayer will present the draft IDR Bgp Attribute Announcement, and then Kayer is going to give us a little summary of Lsvr. I am querying, going to take a moment to ask folks if they know anything about what the best chairs we're interested in with asking us to help with BGP Next Top changes. In the meantime, between now and IETF 1115, I hope to meet with the best chairs and get that information. Kaliraj has a proposed set of information on IDR multi-hop next attribute. Are there any other things that you'd like on the agenda? And I see Jim with a hand raised, maybe not. He seems to have gone off. Did I miss that in the queue, Jeff, or do you have anything else?
I have nothing else. I'm just leaving my microphone attached with mute on to be able to speak fast.
Let's see, that looks like I'm back. Then I'm going to go ahead to the chair status. I've been sending Delta status out. I'll send this information out as well to the mail list today. We have, since the last interim, we've adopted 3 drafts. Draft Jang, IDRTS flow spec v6, SRv6 policy. The next steps, Alvaro, you'll find a request from me, I hope in your email. If not, I'll send you another one today. If you don't have it, just send us a note in chat. On whether this should be standards or informational, there are 4 people who have followed this policy. And so they could go immediately to working group last call. Draft Scudder BGP entropy label was merged with draft IDR next top capability. Draft Spaghetti deprecate 8, 9, 10 was adopted to keep the registry clean, as we feel those that was useful, but we're not making any other additional statement on punishing or going after folks. We just think that it's important to keep the registry appropriately clean. There are still drafts in the adoption process. Draft done by IDR 5G Edge Service metadata received enough desires for adoption, but there's a second CAN BOF, and the AD has asked us to wait for the result. And John Scudder is leading that BOF, or is the AD for that BOF, and I believe Linda is still leading that BOF. Is draft dung draft dung IDR node target extended community is in adoption from now till the 19th. I've extended it because apparently I did a poor scheduling job and schedules it in the middle of Chinese Golden Week. That's like sending it during the Christmas holidays in the US. And then I've started a working group adoption call for Haas IDR diffract 0. Now I'm going to go through the key points from draft Jong IDR node target extended community. I had 3 questions in the call. Will this new transitive and extended community help operational networks? What conflicts do you see with other functions, and do you have any concerns? The concerns raised were withdrawal handling, priority between NT and RT and RTC, and what happens if a PE and an RR with this are on the same node. I'm sure there'll be good discussions in the mail list. There have been a note that several people were interested in deployment SRv6 networks. Jeff Tensura indicated this might be useful in data centers, and the benefits that are looked for are reduction in policy distribution. The implementation concerns were post-update filtering. That is not a standard defined in RFC 4271. So that's where we are with the call. We'll continue to discuss that on the list, but I thought I'd at least bring you up to speed. Any questions about the status? Go ahead, Agent. And
Hello?
Go
Can you hear
ahead,
me
Agent.
now? Hello?
Not.
Can you hear me now?
Jeff, am I failing to do something as a chair to get him to be heard?
I can hear you, and I can hear him.
Okay.
And I cannot hear Agent very well. Okay, we'll go ahead without me. Go ahead, Agent.
So I want to know how to forward our draft VPN prefix ORF. I think we have.
Good.
Yeah.
Good question. I still need. That is the one. One piece I have not written up the results on. So, Agent, I hope to get to that by Saturday evening, and I will send it to you first, and then send it to the working group. So thank you for your patience. I have been working, but I did not get that one done, and you are correct. I did leave that off of the status. I will add that.
Okay.
Thank you very much.
Yeah. I want to say that we have updated the draft again, and the update content have addressed the concern during the adoption call. So I think you can review the most recent draft. And I think
yes.
I think if possible, we can discuss it at the IETF meeting face to face for the possible possible problem. Okay.
Yes, I will be at ITF 115 and we can talk about it there, but I do not have any additional feedback right now. I still have to finish my chair's review,
Okay.
and the chairs will talk about that again at our meeting tomorrow. Thank you
Yeah.
for
Okay.
reminding me I mentioned that. I really appreciate it. I'm sorry I missed that.
Thank you.
Thank you.
Mm.
Anything else before we go into the next slides?
So if we're working through document status, a thing for this set is that I had intended to put out a working group last call for BGP Long Live Graceful Restart starting earlier this week, but I had some work travel that unfortunately interfered with it, and that should be happening starting probably tomorrow.
Awesome. I look forward to that. I'll add both of those to the IDR status wiki. I believe the status wiki is up to date with the time frame for agents. And Jeff, when you do the call, I'll update the status wiki. Folks, I try to keep the status wiki updated. Okay. Will anything else? Any other comments on our status or on the agenda? Okay, I will go to the next slide. Just a minute. Okay, so this is us in a series of presentations. I finally got to a summary of the issues raised during adoption. I've got the general high-level presentation that we did at ITF, but I've now sent out to the working group a list of the operational issues. This list includes working through a long list of issues. I believe G loaded with the materials this long list, but I'm going to go through it. So let me first just note that when we got to 829, there were some comments about new NLRIs and support for V6. This is what the CAR folks said they were addressing first in the GitHub. And as a reminder, this is where the CT. Now let me go through the issues. These are the issues that were raised. There were 6 issues raised for CT. The detailed list that I sent out yesterday, both in email and in put on the wiki, has specific descriptions for all of these. And I ask only if you have any questions. The long list is for the authors to try to improve their documents so we can get to working group last call quickly. There are the issues for CT. There are the issues for CAR. The issues around CT are listed here on the left with SAFI, scaling, CT and RTC, NRI format, and these are the titles of the mail list sequence. The descriptions give the actual that I sent out, give the actual things that should be loaded to GitHub. These are the CAR appendix A7, BGP CAR consensus on resolution stream, handling of LCM car routing and non-greening domains and unpacking. Now, the details give enough for the car and the CT folks to actually have some action items. They've been reviewed by both the car and the CT editor teams. In some of the cases, we had work issues raised by the working group. Shuan raised a really good issue on new address family. Zhenong Xi raised a good issue on support. Bruno has some really good discussions on differences in scaling, and Keitan mentioned things on intent for service, and Jeffrey talked about some implications of CT and CAR. One thing that was extended from here are some of his comments where other domains could be connected to BGP. That might have been an extension by the chairs, but it was a useful topic raised. Swadesh mentioned something on what are the pros and cons on route targets, and there's a compatibility of BGP, CT and CAR to SRPC, and of course scaling. And that's one of the concerns that seems to repeat over and over. Some of these issues in their details may be extreme details. Now, what's important here is that the team, the editors, will be in charge of resolving these things on the IDR GitHub. The IDR GitHub is listed on the IDR homepage. You go to the top and make sure you find how to get there. You can add lists to the GitHub if you have a data tracker, or if you have any problems, contact Jeff I or KR and we can get you into the IDR GitHub. The GitHub methodology is being used so that we can track comments made on the list, the resolution that the chairs think needs to be done, and then what changes are made to the document. That will give us a point-by-point discussion on the document. We've used that also for IDR's work on FlowSpec. That was on a private GitHub because we didn't yet have the IDR GitHub. Christoph helps us set up for that. The authors that I worked with on the FlowSpec, we were revising a spec. We found that to be very helpful. So we have, and I mentioned that experience to Jeff and Kara, who are very frequent with GitHub use in their businesses, and we agreed that an IDR GitHub would be useful in this case. Are there any questions about the document I sent out or the process we're going through with CAR and CT? Jeff thought this might be a quiet time. I will give you a few more minutes. I'm going to remind you, this is what CAR said it was. This is what DJ and Swadesh said the first thing they thought the working group could help with: current version updates in SR flows, updates in filtering mechanisms, and input on use case. One of the things that we'll need here, and I hope Bruno and Shuan and Jinran and Keitan and Jeffrey and Swadesh, we may need help with the scenarios that were described there. And in the detailed list for these issues, some of them I have noted that a chair and the original poster will need to work on getting a clear operational description. And so I hope I can count on all of the posters to help the chairs come up with a good solid use case topology description for the authors to work on. Okay, Jeff, CT's first thing. Now, there is one thing with CT in my review. Some of the comments that are working on, are looking at it, had to do with the applicability of the SR routing architecture to non-SR work, and its architectural link to things which are not SRv6 in BGP. I've called that out separately and asked the CT folks to try to describe what they think should be the limits on that. There's also a best trust SRv6 best services. There seemed to be some discussion on where is the how is the SR architecture predicting the future, and I will try to deal with that as a separate item and bring that back to the ADs and also the spring chairs and best chairs. Any questions? Okay, I think I'm pretty much done. Jeff has the interoperability document. It's now in working group adoption. The next comment may be quick in that Jeff is just going to, I think, take questions. So I will then hand the presentation time over to Jeff.
Okay, thanks, Sue. 2 quick comments. The CT and CAR documents both have GitHub spaces allocated. The CT authors have uploaded theirs. Dhananjaya and Swadesh, please work with Kayer to get your document uploaded. That will be an important part as we go through the review portion of the process and as we start flagging issues. To seed the conversation for the next portion of the interim where we talk about next top types, I'm going to be partially recovering the information from the Diffract presentation that we had last interim. So this is not meant to be an entire review of things, so I will be speeding through several of these things just to hopefully get to the important things for the interim today. So as a reminder, the Diffract document's there to basically say, here's how we could actually do some flavor of interoperability between CAR and CT using each of their native formats and traversing more than one domain that is covered by each of the different proposals. And the 2 sort of key details is that we're covering the forwarding behaviors, and that will actually cover most of the presentations that follow here. Because most of these things are about how do you handle packing your next tops along with forwarding information like labels, etc., SIDs. And the second detail is, of course, how do you map between NLRI keys between each of the proposals. So again, quick reminder, and this ties very deeply into the presentations as we move forward. Each of the proposals have some support for the 3 core behaviors that we're looking to take forward. Standard label stacks, just like LU handles, SR using label indexes, and SRv6. The SRv6 is worth, I think, additional flagging because as Sue was flashing for one of the issues on that CT had raised, the RFC that came out for SRv6 with transposition didn't exit the best RFC process without some level of controversy. Basically, if a next top gets reset, there's a possibility that the transposition label may no longer match up with the underlying BGP path attribute in cases where the systems downstream didn't necessarily understand things. And this fundamentally is a next top scoping issue, very similar to what Bruno had raised as we were working through the BGP open policy stuff, and what do we do in cases where we exit a given zone of comfort. And also this overlaps the situation that we have for the Enterprise label RFC. The original RFC that went out had exactly the scoping issue, and that was exactly what deprecating things was about. The Juniper ELC v2, which was shipped in Juniper internal code, but did not have a matching IETF document, addressed that issue by basically leaving a breadcrumb inside of the path attribute. And John and Bruno will likely talk about this later. And the next stop capability feature has a similar set of discussion points about how do you resolve these things, and the scoping of that I'm sure will be covered in that presentation. So for the NLRI keys, just as a brief reminder, in CAR we have two pieces of state that are involved, a prefix and a color. And for CT, we have a prefix and a route distinguisher, being an operational construct. And the key detail for these types of features is where's the color. In the case of BGP CAR, the color is part of the NLRI, and that is the original intent. And it's possible that if the domain changes such that the original intent can no longer map to the effective color due to mapping reasons within that domain, a extended community is used to carry that behavior. In the case of CT, it always lives in an extended community. So what are we talking about for interop type behaviors? Again, I'm not going to spend a huge amount of time on this because what we're trying to get to is discussions on forwarding behaviors. For a given BGP route, in the very formal sense, a prefix for or NLRI, whatever that happens to be for your given AFI-SAFI, and it's pairing with the path attributes. Can we map from one mechanism to the other? The answer is yes, we can do that mapping, but it requires some level of carrying breadcrumb state between them. And color is obviously one of the things. The original intent idea in card going into CT is one of the things, and vice versa. And how this gets mapped quickly. So this is an example of passing between multiple domains as one of the use cases we'll have to discuss. And I continue going through this very quickly. So the mapping machinery here is largely being done in the format of extended communities. One of the things that is a update to the document that needs to be made is that carrying the original route distinguisher will require, if it stays in extended community format, 3 mappings, because we have 3 common extended communities for these things. The critical detail here is this is the state that needs to be mapped. And if extended communities don't end up working fine, they can go inside of a path attribute. This is, again, just a mechanism for carrying the information to sort of push and pop the state as you traverse one domain to the other. And we're only ever looking at one set of things. Theoretically, we could actually do something very similar to what the adder set can carry, but the actual detail is the point to refine. The procedures in terms of what we're doing, extend community or path attribute is a discussion point. Going to bypass the slides covering the individual mappings. The critical thing is that as we go from one domain to the next and maybe repeat that through several different cycles, consistency of route selection needs to be preserved. So when you're inside of a CAR domain, the routes that you may have learned from CT need to compare equally, and vice versa. And this means that we have to have consistency in what the NLRI keys look like as things are remapped over multiple processes. I had discussed in the original presentation, again, leaning towards the discussion of what do we do about forwarding behaviors. If we were to have something to look like a merge solution, RDs have enough space to carry a color. So this is one thing that we can potentially look like it as a way of carrying both CAR original intent for operational cases where that's the desire, or CT style operational intent where the endpoint devices are what the operator is interested in. Both can fit in something that looks like an RD, and the presentation gives some sense that an RD can actually accommodate a color as well with a new code point. And of course, the question really is about forwarding. And this is our lead off into the discussion points for the later pieces of our interim here. So the observations the CAR authors have made on CT is that mandatory labels may be inappropriate for some encoding styles for forwarding. SRv6 is an explicit example they gave. CAR optional NRIs have some very nice properties. Theoretically, they may allow us to have a level of generic route reflector behavior. One of the things that's a interesting point, which we'll have to probably use as one of our primary pivots if we decide to go with something like optional NRI as a general mechanism from this point forward in IDR, is that RFC 7606, the BGP error handling RFC, we spent a huge amount of work in that, and one of the key bits of wisdom that came out of that effort is that we want to keep the NLRI basically as undecorated, as plain as possible, and basically at the top of the packet, because that gives us the ability to do treatise withdrawal type behaviors. And that's the mechanism that we have largely fallen to try to preserve a BGP session staying up in the presence of some level of encoding errors. So we'll have to address this as one of our key points as we have this discussion. And the motivation for doing any of these interesting things is, how do we actually get better packing? The problem that we have for the packing discussion, and I do see that there's questions, I'll get to those momentarily. The key thing about packing that we have to worry about is that we know that packing can have immense performance benefits on BGP implementations. So there's a strong incentive for us to use better packing whenever we possibly can do so in a reasonable fashion. It's a great bit of accelerant for letting BGP perform well. The challenge that we have, in the terms of even some of these optimizations we're looking at, CAR being an example, is that when we allow for this sort of thing, anything that causes the path attribute sets to basically stop being shareable, and that's usually BGP communities or other attributes that may go on there, this degrades our packing. So one of the analysis spaces that we should have as we're working through these proposals is, when we have a desire for packing, what is the likelihood that packing can actually take effect? This is specifically for attributes that either are currently present or may be present in the future. And to give an example of in the future a conversation, both CT and CAR currently don't talk about the tunnel and caps attribute as one of the things that they can carry. It seems a potential feature at some point that that may be used to bias the tunneling information for each of those proposals. Clearly, that's not there yet, but that's just an example of a place where degradation could happen. And this again goes into our discussions. The original speculation from the last presentation was, what do we want to do? Do we want to stick with the CAR style encoding with the good things that it has, and maybe live with some of the awkwardness that gets introduced from error handling? Do we want some new next hop type? Do we care about next hop scoping? This ties into several other presentations that are following. Or do we look at maybe this is a time for us to look at maybe a update to the BGP NLRI itself, sorry, not the NLRI, the BGP update packet, and how next hops get encoded. An example of how this might be able to be done can be compared to the grow BMP feature, where they're tying stuff together, through basically array indices inside of the packet. So this has been the setup for most of the rest of the discussion about BGP next hops. Reading John's comment from the Meet chat, he agrees that keeping the NLRI simple as humanly possible is a good goal. People are going to have various views on this, and this is where we're hoping the discussion will go over the course of the longer presentations. So before we move into that next set of presentations with this as a setup, any questions that this presentation raises? Okay, there appear to be no questions, Sue. Stop sharing.
thing that I wanted to note. When you said that the SRv6 problem that we noted was only related to scoping of the next hop, or scoping, it's only a scoping problem. I think that may not be completely accurate, because it's also a problem of how that transposition mechanism interworks with MPLS devices in the same network which are not upgraded, because they may misinterpret the transposed portion as a regular MPLS label. So that was the main problem.
Exactly, and from my perspective, that's effectively a scoping problem in the sense of clearly that RFC overloads existing behaviors, and it's a problem when you have left a portion of the network that understood the feature. So as long as you stay within the little bubble that's defined by where this feature works, theoretically it can work perfectly fine. But the mechanisms for ensuring that you don't leave that bubble are not part of that RFC.
But it also assumes that every node in that network supports the feature.
Or at the very least, you can restrict the routes to only the portions of the network that do understand it.
Yep.
Ketan?
I think I wanted to confirm what you said last, that the draft, the RFC does cover, and the scoping is based on config, so it's config scoped. The mechanism,
Understood.
there is an assumption that every node in the network understands this.
Right, and to some extent, when Sue had started the discussion about the best chairs and discussions about next hops, there's a discussion point that we're seeing being more and more relevant across, especially best related documents and even IDR itself, is what do you do about incremental deployment? How do you make sure that a feature doesn't leak out of a place that it doesn't understand, it doesn't have bad consequences when that occurs? So at least one of the presentations we're having here is about generic scoping discussions. Several of these are about next hop scoping. Sue?
I'll just introduce the speakers. By John, you're first up. The next hop discussion started when we were working in the entropy label and asking about adoption of that. I believe John has some useful details on that, or at least, John, will you cover it? Next, Kayer is going to go through the Bgp Attribute Announcement, which is another draft we've worked on. Kayer is going to list the Lsvr drafts. I'm going to have a moment where we simply ask if people have known issues with best next hops, and then I will use that to research information going forward. And then Kaliraj is going to present a next hop draft that he's written on multiple next hops. And with that, are there any questions about this section? Okay, if not, I'm going to share the presentation, or if John wants to run it, do I just let him share since he's got chair privileges or AD privileges?
I don't think I have any magic privileges in this room.
Okay, so let me see if I can figure out how to let you run the slides, or maybe I'll just run them for you.
I can,
Hold on.
here, let me see if I can request to share.
Okay, I'm going to grant preloaded share slides. Hopefully you can see the deck and pick your own. Does that work now?
Nope, I don't have
I'll
it
stop
on.
sharing
wait a
and
minute,
see
wait
if
a
you
minute.
can do it.
Okay, I'm going to click on the Ask to Share button. Hopefully that gives you something to.
Oh, I've grant the access. Let's see if that gives it to you. Oh, love the fact this is working.
There we go. Yeah.
Good. Thank you. Learning something.
I assume you can see that. Okay. Thanks very much for giving us the time. So this is me on behalf of a rather large now group of really productive collaborators. And I would like to say a very sincere thank you to all of the co-authors and contributors listed on this page. It's really nice when the IETF process works the way it's supposed to, and we can work together collegially. I love it. Okay, so let's start with a little background. And the background is that for some applications, it's really helpful if we know something about what a remote BGP speaker is able to do. And in particular, we know something about its forwarding plane. I'm not 100% sure that we can restrict the scope only to forwarding plane, but certainly that's what our current use case is, which is knowing whether the tail end of a LSP can process entropy labels. And we covered this in a lot more detail at IETF 114, and I'm not going to go into the details again now. But you can refer back to that talk. And because of the context that we're presenting in today, I also thought we should emphasize that although next hops play a part in this proposal, the way that this proposal makes use of next hop is as a thing that as an identifier, really. As we'll talk about more, the current draft is a merger of the ELCV3 and the next hop dependent capabilities drafts. So next hop dependent capabilities, the word dependent is important there. We're not changing anything about next hop processing. We're using the next hop as a key to tell us if the attribute applies. So let's talk for a minute about document development. So we recently had a working group adoption for ELCV3, entropy label capability version 3. And there were a couple of suggestions that came up from a number of different participants in the group. And the two themes that we saw were, one is, why the heck isn't ELCV3 a next hop capability? And in fact, if you look in the next hop capability draft, you will see that it has an entropy label capability in there. But people also recognize that, hey, there seems to be a need for the next hop capability to be transitive. And that's basically has to do with insertion into existing networks. So we worked together to produce a merged draft, which we posted a couple days ago. And because choosing either one of those names seemed a little confusing, and for various other reasons, this is now called the Router Capabilities Attribute, and short name RCA. So when mergers go well, they take something from each of their sources, and this merger I felt like went very naturally, and it took one major ingredient from each of its sources. From ELCV3, it took the strategy for making the attribute transitive while still being able to couple the capabilities to the next hop. So what's the strategy? It is to carry along the IP address that was originally inserted into the next hop by the routes originator. You take that and you copy it into the header of the attribute. When the receiver is deciding how to use the attribute, it has a look at the BGP routes next hop. It has a look at what it sees in the attribute header. If they match, great, process the TLVs. If they don't, oh, this wasn't ever supposed to reach me, and it gets discarded. And then from the NHC draft, comes pretty much everything else, the TLVs and the rules for how to propagate them. The TLVs look like a classic TLV, 16-bit type, 16-bit length, and a type-dependent value, which can be 0. And then we just make Lsvr very much similar to the entropy label capability that was in the next hop capability. So we can see this graphically as well. I'm not a huge fan normally of inserting packet diagrams into slides, but this time it seemed like it would be useful because it illustrates, I think, quite well what happened with the merger. So in ELCV3 draft 0, this is what, and I'm not showing the attribute headers in here. So you have to imagine the standard Bgp attribute header. This is the content of the attribute. So ELCV3 has this field that, or set of fields that identifies the next hop. And the proposal in ELCV3 was the existence of the attribute is itself the signal that entropy label is supported by the tail end. By contrast, the next hop capability attribute would, and assuming that you're advertising entropy support, would have looked like this. It's just the attribute header plus capability 1. Put them together, boom. It's the header that allows us to make the thing transitive and the capability. So thanks, Aijun, for bringing up some discussion points on the list. And what I captured were 2 things. One was, why should we have this, I'll just back up, why do we have the AFI and the SAFI in here? Since you can actually infer that by looking at the rest of the update. And at least part of the answer is, well, it certainly seems better for parsing this thing to have the attribute be self-describing. For one thing, if you think about our rules for Bgp update encoding, an implementation is supposed to put the attributes in order. The implementation is supposed to put the npreach attribute in first, but an implementation is also supposed to be able to process things in any order. So what that means is that when an implementation reaches the RCA attribute, there's no real guarantee that it's going to have access to the, or that it already will have gleaned the context to tell it how to parse the NLRI field in the attribute header. And I think that just also as a general policy, it seems like good practice to make attributes self-describing to the extent possible. And then the other question was, oh hey, the NHC draft contained readable label depth as an optional field in the entropy label capability. Why did you leave that out? And the answer is, well, this kept, as we showed in the previous set of slides, this kept really close parity with the existing ELCV3 syntax and semantics. So we can discuss this further, and if it's urgently needed now, we can certainly put it in now. If it turns out later that it's needed, we have a 16-bit code point space, so we can actually manage these capabilities the way that we would always like to manage everything if we could, which is just add a second code point that has the exact semantics we want. And I seem to be talking about naming of things a lot lately in different contexts, and this is one of them. So what's in a name? It turns out that, naming things, although it's kind of boring and seems arbitrary and silly sometimes, it matters because choosing the wrong name can confuse people for years to come. So we currently have a working name, Router Capabilities Attribute. Here are some of the other things that were discussed or thought about. Next hop dependent capabilities, of course, is from NHC. We could call it next hop capabilities attribute. So one of the problems with that is that it can lead people to think that this is something that changes next hop processing, which is something I tried to defuse up at the beginning of this talk. We could call it a transitive BGP router capabilities attribute, which both speaks to the fact that it's literally a transitive attribute, but it also speaks to the fact that it's a capabilities attribute that is meant to be available all over the domain and not just to the neighbor the way the open capabilities are. You call it forwarding plane capabilities attribute, which I think is quite nice, but it then kind of presumes that we're only ever going to use these things for things about forwarding, which that's our use case now. I'm not sure if it's our only use case in the future. So, you know, Floor is open, preferably I think on the mailing list for discussion of other possibilities. And I see Kira's put something in the chat, and so have Jeff. And I'll look at that by and by. And then second point is it kind of rubs me the wrong way that we call these things capabilities, because we already have RFC 5492, you know, open capabilities. But I didn't have a better idea, and we wanted to ship the draft, so it is what it is at the moment. And like I said, let's discuss on the list if you have a good idea. Would love to hear it. And then finally, you know, never come to the working group without asking for something and knowing what you're going to ask. And what we're asking for at this point is we think that we're ready for early allocation of a code point. If you look at the process in RFC 7120, there's 4 things that have to be ticked off in order to say, yeah, this thing is ready. And generally, the one that's can be most problematic is this one, C, which is the specification stable enough that we can allocate this code point and know that it's not going to, you know, the syntax isn't going to get changed out from under us. And we think the answer is probably yes. We have a reasonable amount of experience in the field with the strategy of using the header depicted on the previous slides, you know, with ELCV2, which we talked about at 114. So we're pretty confident that works well. There doesn't seem to be a lot of debate about using that. There may or may not be disagreement about how to encode the entropy label capability itself, the TLV, but the wonderful thing there is we have a very large TLV space, so any changes would, exactly as the RFC wants it to be, would be backward compatible. So next steps, we'd like to request early allocation, and we can get to work implementing it and last calling it. And I'm done talking, and I'm ready for any questions. Thank you. If there's no questions, oh, I see 2 questions or 2 hands raised. So Jeff, please. Jeff, if you're speaking, we can't hear you, or I can't hear you anyway.
I'm double muted. That hopefully is better. So something I think that might deserve a little bit of commentary, and I think it's probably going to be the messiest thing of any of these proposals, is there's always going to be the discussion what happens when the mechanism you're using to detect that you've left the scope of what you're expecting this to work has failed. What do you do? And I think the general flavor of at least the original ELC was, well, for this one specific thing, it's okay, just do standard hop-by-hop behaviors. You're losing all of the extra signaling that came along with the ELC. Do you think that bit of thinking will hold up with all of the unknown things that are likely to be packed into the additional capabilities that this is enabling?
Well, they're unknown things, so the only honest answer is I don't know. What I do think is that, we say in the spec, and this is language that largely came from NHC, so it's made a few rounds in the working group already. What we say in the spec is if you're defining a capability, you need to be explicit about what the rules are for transitivity of that capability. So I kind of think we can't do better than that without knowing specifics of the capability. I think specifically with respect to entropy label, again, when we thought it through for ELC-v2 and so on, it seemed reasonable, and I still think it seems reasonable. So I don't know if that's a sufficient answer to your question, but that's what I've got right now. And if there's no follow-up, I'll call on Ketan.
John, a couple of questions. One is in this is when we call it router capabilities for the entropy label ELC use case. I believe this is originator router capabilities, right? That's what is being carried or conveyed.
Right. It's the LSP tail end essentially.
Correct. Right. So that's the originator router capability, and then there can also be I don't know the use cases right now, but there could be the next hop capabilities. That is probably the next hops which keep changing or not changing. Should we not differentiate between the two? So one is a originator router capability, another is more of a the actual BGP next hop capability.
Well, I guess the how we got to this place to begin with is that when we change the next hop, we are changing the expectation of how the thing is going to pass through the forwarding plane. So it's not really the originator router capability per se, because if we think about a route that was originated someplace across the internet, and if that router over there is capable of processing entropy label, but then it propagates through the internet for a while, crosses some AS boundaries, gets into a new AS. Within the new AS, the border router there sends it into IBGP, gets over to a different border router. What you really want to know is, like, for the within the scope of applicability of that particular LSP, can the tail end process entropy labels, right? So
yeah,
the thing that has those semantics to tell us about that is the next hop.
Yeah, so where I was probably getting to is let's say tomorrow we have another capability that we want to advertise, but that is not the LSP tail end, but some other the actual next hop, which is in the BGP next hop attribute for that node. Can we do that? How do we do that? Can both be put in the same, or should we have separate separate attributes for distinguishing them?
Well, I get part of my problem is I'm struggling to understand the use case, and it might be that we should. I'm not sure how much time we have, but if I don't catch on soon enough, we can maybe take it to a side conversation. But the other part is that I would answer is, like, if is this a little bit glib, I suppose, and I apologize for that, but is that if the semantics we're providing here works for the use case, then excellent, we can fit it in, and if not, we should create a new mechanism that works for the provides the needed semantics.
So Ketan, Satya, John, we could just have a different capability of what Ketan is proposing, right? In the same attribute.
Yeah, that's exactly what I was trying to say. Thank you for saying it more clearly. is that, if we need new semantics, then we should define a new attribute that provides those semantics.
Okay.
Thanks.
The second comment was related to coverage for the for Anycast scenario. So let's assume that the same prefix is advertised. That's LSP tail and Anycast are advertised by two routers, right? And then they come to one router where who's doing a next stop self, let's say. So now. I mean, this may be probably a corner case, but one of those two could have an entropy label, the other could not have an entropy label. Is that something to be considered, or at least discussed, I guess?
It's absolutely something to be considered and discussed, and thank you for bringing it up. I'm not sure if it's something that we have to fix, but it's minimally something we have to think about. Thanks for raising it.
Okay, thanks.
Thank you. Kalaraj, please.
So just reiterating, I understand it right. So it is not the originating router capability, right? It's just the BGP next hop router capability.
Yep.
Yeah. And the second question, the question I had was, so we also extract the next hop IP address from other places than next hop attribute or the MPV channel array, like redirect to IP extended community is one place, or there are some places inside the tunnel and cap attribute, or the color only community that also gives us a next hop. So does this next hop capability, it applies to any of those, or is it only to the IP address found in attribute code 3 and attribute code 14?
That's a great question. I don't have a good answer, but same as the previous answer, I guess, which is absolutely we need to think about that.
Sure, thanks.
And KR, please.
Hi, can you hear me, John?
I hear you well.
Super. Hey, you said yep to what Kaliraj asked, but this is a originating router capability, the one that originates entropy label, right?
Well, I mean, I guess it depends on what we mean by originating, but when I was answering the earlier question from Ketan, I was sort of spinning an example where some route is originated into BGP far across the internet, and it goes along, and then eventually it reaches an AS that propagates it into IBGP. So I wouldn't call that border router that put it into IBGP. I wouldn't call that the originator. I would call that something else.
It's something else, but it is the router that originates entropy label. You could call it something else, but let me make it very simple. If route reflector in middle replaces the next hop, it's not intended to insert any of its capabilities. Is that correct?
No, that's not correct. If it replaces the next hop, the route reflector should do the right thing, right?
Which
so is? If the route, it's all spelled out actually in the draft, first of all. But if I can try to summarize it off the top of my head, if it replaces the next hop, minimally it should throw away the attribute. That would be the polite thing to do. If it doesn't throw away the attribute and it doesn't modify the attribute, then the receiver will look at it and say, the next hop doesn't match, and the receiver will take care of the throwing away on the route reflector's behalf. And that's like actually the whole insertion strategy there, right? That's why we do it that way.
That answers my question. Thank you.
Okay. Yep. Thanks. And with that, I think the queue is empty. I see a bunch of things in the chat, but I'm going to assume that they don't need to be handled on mic. Thank you, everybody. And I'll try to figure out how to stop sharing here. But I think the chairs can probably take the sharing away from me. Oh, Satya, you have your mic on. Did you want to make a comment?
No, I just wanted to mention about the Kaliraj's comment. So We can put that in the draft, redirect when we are changing the next hop, as in like the denial of service type of cases, right? So we can extend we can put in a mention there in the draft, I think.
Yeah, I've taken some notes for things that we need to follow up.
Thanks, Doug. Yeah.
Right. Thanks, everybody.
Carrie, you're next on the presentation list, so just grab the presentation rights.
I don't have an access to the presentation. Do you want to just show it up and maybe control it? So are you sharing a deck or? Sue, are you sharing? Are you sharing the deck?
Sue seems to be having some problems. Let me go ahead and see if I can share if she's not able to do so. Actually, within the pre-shared slides, I'm not seeing anything for your presentation, Care.
Do you want to go to next presenter and maybe I can send my slides or see if I can upload it?
Yeah, use the upload tool from here. I think that would be the appropriate thing to do. Not sure why Sue's not able to speak. Sue, you maybe unmute again.
Hi, I took the mic off. I've got his slides on my laptop ready to share in presentation mode. So let's see if that works quickly. Okay. Nope, I've got it, but it. Okay, how does that look? Good, Care? Can you see the slide set?
Yep, looks
Is
good.
it?
Thank you.
Okay, just tell me
Um,
when to move.
I think this is the second presentation, so one before.
I don't have that one, so you're gonna have to load that in the pre-share slides. Let me go back to what I think I'm supposed to have next. Give me a moment, I'll stop sharing. Go to the next one, Care. What I thought I had here in the agenda, I thought I had the BGP attribute. I don't have the attribute slides. I only have the Lsvr changes. I don't have the other one pre-attribute.
Okay, let me
So
see if
you're
I
gonna
can.
have to load that. We can go with your second slide set. That's what I was doing. What do you want to do now? You want to see if you can load them?
Yeah, let me try and see if I can share my screen.
Okay.
It's not allowing me to do that.
It should try again. I have my screen shared. Okay, you've got it.
We can see the full screen. If you go to presentation mode, that might be okay.
Now?
We see the full screen. Just need to go to presentation mode so that we don't see, like the stuff on the sides.
Whoopsie. It's not allowing me to switch. 1 second, please.
Yep, it's the icon at the very bottom of the screen that looks like, I think, the 4 panels.
Excuse me, can you? I just uploaded your slides. Can you check whether you can find it? I'm
Okay,
putting
so do you want to
the
enter this?
Just, I've got to see if I can check the preloaded again. Hold on. Yes, I've got it now. Nope, I'm still getting Collie Rogers. Hold on. Jeff, did you pick up the sharing? Okay, I can't pick it up. Care, you should go with. I'm not seeing it show up in the deck yet, G. So why don't we go with your mode of showing your screen? Unless you see it, Jeff.
Okay.
Or screen.
It is just not allowing me to get into a presentation mode.
Why don't we go with this one as it is? I
Do you
see
see
where
it?
it's not. Yeah, I
Do
see
you,
it's not going in. The only thing you can do is cut out the side met by changing the layout. Just go ahead. Let's go ahead with this one, and we'll post the slides.
okay. So I'm going to talk about the constraint attribute announcement draft. This is already a working group document. The main motivation for writing this proposal was that currently there is no mechanism inside BGP to scope the announcement of optional attributes. The only possible way to do that is either you define it as an optionally non-transitive attribute, which means by definition it will be filtered out at ACE boundary. You have some error handling filters that you've defined for malform attributes, and that forces it to drop the attributes. Or you have attribute specific rules that you define per attribute, and that will do the needful, right? But what was needed, or what is needed inside BGP, is to have a scoping mechanism that is inbuilt for attributes, wherein you can automatically scope these attributes at either a confed boundary, AS boundary, or at multi-AS boundary. And there were certain interesting use cases where you could have done this. One was a tunnel and cap attribute. Next hop capabilities attribute was another one where you could automatically, set a bit and say this should be filtered across the AS boundaries based on how it was done. BGP timestamp attribute is another one where you could do it, and any new attributes that are being defined that need scoping. So the solution was pretty simple. We didn't want it to use any capabilities because we think this is integral infrastructure part of BGP, and you want to do it within the BGP itself. So as a initial solution, we didn't use any capabilities. We just stole 2 bits from the attribute flags where you would mark these bits, and if these bits are set, then you would do the needful. And we wanted to go to INR to reserve this bits in the attributes, and that would do the needful filtering, right? Again, this bits should only be set if the optional flag is set on the attributes, which means only use it for path attributes that are optional. The filtering has to be enforced, so operator needs to ensure that if it's deploying this solution, then the filtering is honored at the boundary within the AS, particularly, or if it's a multi-AS within the same administrative domain or confeds. The error handling rules are also set forward and defined very well in the draft itself. And then last but not the least, 00 version was presented in 94 IETF. It's again a working group document. Draft is in a fairly decent shape. We are awaiting implementations. Any questions?
Okay.
Hey.
So did you say the operator needs to enforce it or the implementation? The software automatically does it?
So the implementations have to enforce it, but operator has to be mindful of the fact that two ends of the routers if you're setting it at on certain set of routers, then at the point where you egress out, that egressing router has to filter also, right? The path attribute.
Will the mechanism described in the draft itself not guarantee that?
But if the code upgrade is not done on that router, it won't, right?
You mean for the optional transitive attributes?
Yes.
Yeah, that's what. Yeah, I was
So,
wondering how it works for transitive attributes. So probably.
all I'm saying is assume two ends of the routers at 2 points at the edge of the network. Once inserting an attribute and then saying, hey, this should be filtered across the AS boundary. Now, when you reach actually the AS boundary, as long as that router implements this behavior, you'll be able to filter it. But the operator needs to ensure that the router has indeed or is indeed enforcing and filtering this, right? Otherwise, it can get leaked out.
For the optional transitive attributes. Yeah,
Yeah.
that was one of my confusions, how it works for transitive. And the other thing is, you say the multi-AS capability. How is that done? Because we don't specify any AS numbers or anything.
Right. So again, this is more along the same lines as we discussed, that a multi-AS is under a single administrative domain, and the operator of that administrative domain has to ensure that, hey, this set of routers are actually at the border point of a multi-AS domain, and they have to set a policy that says, the filtering has to be done, and the attribute now that is transiting across the multi-AS domain should be filtered, right? So that
Wouldn't,
is somewhat policy defined operation.
okay, wouldn't it be good if we just carry the set of AS numbers which are cooperating in that domain so that it can be done automatically by software as well?
We could, but this was a path attribute flag. So yeah, we could do that, or you could set it as a local implementation policy as well that says, across this eBGP connection, you're truly transiting across a multi-AS domain, and therefore, honor the path attribute, which is bit which is set that, hey, this should be filtered at the multi-AS, just honor that and filter it out. So you could think of a policy that has been set, and based on the attribute bit that is being carried in the packet, you now have an ability to match that and filter it. See what I mean?
Yeah, I just have a feeling that, I mean, making it more automatic in the protocol may avoid human errors.
Sure, we can talk about that.
Thanks.
Most definitely. Ketan?
Yeah, Keyur, maybe a naive question. We have 4 bits in the attribute options or flags, right?
Yes.
Are they usable?
Yes.
don't.
I have
Instead of this,
actually yes, I've taken actually a unused 2 bits out of those 4 bits and used it to mark both multi-AS as well as confed and across the AS boundaries.
okay, but not for the okay, but then you needed more, I guess. That's where the other.
Say that again.
Uh, okay, I'm sorry, I misread it. My apologies. Thanks. Yeah.
No worries. No worries. Jeff?
So looks like I have the queue. So discussion point that we have here is basically a couple of different things. The first one being that we wanted to discuss having this sort of thing as a core feature in BGP, as people have said in different ends of things. Trying to do this after the fact is a really heavy challenge. So this is almost a BGP 5 type thing. Currently deploying it is going to be very, very challenging. I think one of the biggest problems we have in terms of the reserved bits, we tried this before, and significant number of implementations on the internet just simply treat those bits and cause session resets. That's why we didn't use this the first round. So the question we're going to have is, again, since this is for attribute scoping, can we figure out a way to basically put the necessary safety bubble around this so that we can make use of these additional bits that we have available? So I think that's going to be one of the more interesting discussion points for the working group. If anybody wants to go look up the history, we tried to use this during the initial set of work on the BGP error handling stuff. There was literally a bit being flagged in there as one of the bits of feedback, and that's where we ran into this the first round.
And I think one approach to that could be we could reconsider putting in a capability and say, hey, if the capability is not exchanged, then automatically drop the bits at the sending side or something along those lines, so that you don't send these bits anymore, but the filtering will not be honored as well. And I think we can add some text. But happy to discuss that and brainstorm it and see how do we move forward with that.
The capability and making it a core part of the protocol. But if it is if we are able to make the filtering work automatically without having to have user configure the filters, then that will be great.
Cool. Thank you, guys. Any other questions? Comments?
This is Sue.
Cool.
You should probably just go on with your second presentation on Lsvr.
So do you want to put that up since you have those slides? Because I'm not able to push this into a presentation mode.
Okay, let me see if I can push it into a presentation mode with full screen. Hold on. I do not have it in the pre-shared slide, so it'll be a presentation mode push. Let me see if I can get it into both. One moment. Gary, you're going to need to see the whole presentation. I will try it. Hold on. Do you see it now? I can't do both, but do you see it now, Gare? As presentation mode?
No, I don't see the slides.
Okay, you best try your other one. I can't force it into presentation mode. And my screen either way, it drops out. So you might as well go with yours so you can control it. I apologize. We'll have to make sure we get the slides preloaded next time.
No worries. Will you give me an access, please?
You should access now as a chair as I've stopped working on pre-sharing. Do you have access at this point?
Yes, I do.
Okay, thank you. My apologies.
Can you see my slides?
Yes, I can.
Okay, so folks, I'm going to talk about BGP-based SPF. This is the work that has been done in Lsvr working group. Sue had asked me to talk about this in context of next hop implications that are there in BGP. Since folks in this working group may or may not know, I thought I'd give you a general overview and then talk about what are the implications to the next hops, if any. So I'm going to go fast through the presentation with a hope that I can give you an introduction and to what BGP-based SPF is, and then talk about next hop implications. Yeah. So the main motivation for the work here was, hey, look, in MSDCs, some kind of a layer 3 routing has been implemented till date that is being used as a fabric. Most of the operators use, to that point, BGP as a layer 3 routing protocol. One difference that people use in MSDC when they use BGP is that BGP and route reflectors, more specifically, if you look at service providers, route reflectors typically that are not in forwarding path assumes the next hops will get resolved over a IGP of some sort that has been deployed for the underlay connectivity. In MSDC, there is no IGP. And the way that has been done is through hop-by-hop peering through eBGP, mostly connections that are being used. So just one routing protocol, no underlay, no overlay, as in two different protocols, but BGP being used for that. And if there is an overlay, then again, another SAFI of BGP would be used. Typically, when you do hop-by-hop routing, that uses distance vector. Now, the reason to use SPF over a traditional distance vector algorithm is that when you do hop-by-hop routing, you typically don't have a complete view of the topology, which is what you want as an underlay. And when you want that, you also want, hey, how do you do fast convergence? How do you sort of scale it better? And when you look at these characteristics, it is almost, it is very clear that you need a graph-based algorithm, which is pretty much an SPF to get you where you want to be. And so if you're going to deploy an SPF-like solution, then and use BGP as compared to other protocols like IGP, and you start to compare them with what is out there with IGP, you can see that the advantages of a traditional BGP-based solution are a lot, in sense that again, BGP is widely understood. It's very, from operational standpoint, it is fully it has all the debugging tools and the analytics in place. So very well understood. Again, the transport for BGP is quite reliable, so it can guarantee in-order delivery. So from a transport viewpoint, it has all the pieces that you need from a protocol standpoint. It doesn't do flooding, and it also lends itself to a multiple peering models that you would want to use, eBGP, iBGP, anything. And therefore, combining a SPF inside BGP looked like a very good solution to start with. Now, when you start to look at a solution like that, the changes that are needed inside the protocol are the following. Obviously, you need to define a new SAFI, new capabilities. You want to make sure multiple peering models are honored, and you want to change the algorithm inside BGP, which today runs distance vector, to actually run Dijkstra, so that you can calculate the SPF. When you start to do that, the best path process changes accordingly. So next, you have the decision process phase 1 and phase 2 are completely replaced by the SPF algorithm. This is what the draft talks about. And phase 3 is decision process is pretty much short circuited. You're running Dijkstra, you're calculating the graph for given prefixes. And since you calculate the graphs, the side effect of that is that you pretty much can now build the underlay topologies that you are looking for it. Supports both IPv4 as well as IPv6. Now, since you're running SPF and calculating SPF, next hops that are carried inside BGP are of pretty much no use. The distance vector algorithm honors when you do hop by hop routing, it tells you which next hop to use for a given route and given path more specifically. And then you go about calculating an IGP matrix amongst other things in the best path calculation process, and then pick the right path. In case of SPF, you are actually computing the shortest path anyways, and that is independent of what other routers tell you. And that is why, in some sense, whatever the next hop is carried inside BGP as part of a mandatory attribute is still announced but ignored upon the receipt of the prefix and NLRI. There is since it is only carrying underlay route, there is a sort of packing draft. While draft doesn't impose any restriction, it is almost implied that you may carry one prefix or set of prefixes that are specific to a given router when you are trying to announce the routes out or connectivity out. But the biggest point about this draft is that, hey, the next stops are not honored. Next stops are ignored because you are looking at the shortest path connectivity, and you are, as a byproduct of SPF, whatever the next stops need to be calculated and set forward to. The peering model, again, is honored. You can do route reflector or a route controller like peering model. Both models can be inline or um, um, not in the forwarding path. And SPF computation can happen itself also on the route controllers, as well as on the leaves and spines inside the data center. So all sorts of flexibility is still provided and honored as part of a traditional BGP offering that has been done. Again, from a status standpoint, working group blast call is already been done in Lsvr. Chairs, I think, are ready at some point to move this draft forward. Multiple implementations exist for this particular solution. And the key point from IDR's perspective, again, reiterating, is that that in this particular SAFI, your next hops are not going to be honored. So you can carry next hops and next hops capabilities, but the next hops in itself are going to be recomputed as part of the SPF process. That's all I have. Any questions?
Um,
Hey, Satya.
hey, on this one, since next stops are kind of like next stops are kind of redundant here, right? So any implementation will do rib resolution right on receiving a route. So what the draft says to like short circuit this process, or
Yeah, so what happens is, since you are running Dijkstra, you will calculate the next hop just like how OSPF or ISIS calculates. And the phase three, which is, hey, calculate the phase three of the decision process, is pretty much short circuited, because it's as natural outcome of calculating next hops for a given route. You will then go and install that in rib straight away. You don't need the decision process. Pretty much you can optimize that path, is what the draft says.
okay, thank you.
Thank you. Any other questions? Over to you, Sue. Thank you.
Thank you. We're gonna, the BGP best draft presentation was simply a query for anyone that knows of next top problems. We're gonna skip that presentations. Please send me any known problems or things you'd like to see improved with best to me directly. I'll continue the research with the best chairs and go on. In the meantime, we will go to Kali Raj's presentation, and this one I do have. Kali Raj, if you just let me run the slides, just say next and I'll run the slides.
Thank you, Sue. So we are going to talk about this multi-next stop draft. Next slide, please. So this is kind of going to be a little bit of overlap over some of the discussions that we have been discussing today. So we'll go through a brief background and describe the problem and see how multi-next stop attribute attempts to solve it. Next slide, please. So basically, as a background, let's have a retrospection of how we express next stops in BGP. Basically, what is a next stop? It's instructions on how to forward a payload specified in the BGP NLRI, which could be IPv4, IPv6, it could be MPLS upstream labels or flow spec. And this next stop information is extracted from various places, various portions on a BGP route, on a single BGP route PDU. And these can be broadly classified as basically the endpoint, that's the next hop, where to forward this to. That can be the IP address that we extract from either the next hop attribute, code point 3, or the MP reach LRI attribute, code point 14. The next hop address is specified there. Or it can be in the redirect to IP extended community attribute, or we also have some TLVs inside tunnel and cap attribute, or sometimes the color only community carries a value that is encoded as a used as a next hop. And then we have redirect to VRF extended community attribute, which says redirect to this VRF. So there the endpoint is not an IP address, but it's still saying that redirect the traffic to a specific VRF. So these are like where to forward the traffic to. And then we have information on what encap to use. So basically it could be a label, which is also carried in the MP reach and LRI code point 14. And it is a label is the NLRI portion of the field, or it's carried as a SID in the prefix SID attribute, or the tunnel cap attribute and repair label attribute, which tries to signal two labels, one for backup path, another one for the primary path is carried in the MP reach and LRI. Or they can be like SRv6 SID inside the prefix SID attribute. And also we have constraints to the route. So which basically says when you forward this traffic to a next hop, how do you want to do it? You want to follow some constraints which are specified by either the color community or any other mapping community, which says how you want to, what type of path you want to take when you want to forward this. And also we have the link bandwidth community, which says what kind of load balancing you want to do. So next slide, please. So those are the things that we have on one route. And now how we express multiplicity is either using add path, where we advertise multiple routes, each carrying a single next hop, like what is explained in the previous slide. And add path, it increases rip scale, and rev scale also is a challenge there. And then we combine this information we get either from multiple peers, single routes from each peer, or same peer, multiple routes using add path. And then we use local configuration like multipath or PAKE. And that way we consume everything and form a unique cast next hop or a multipath next hop, which we install into the FIP. So these mechanisms have organically grown over the period, and information is spread across different portions of the BGP route, NLRI, and different attributes. Most of them are like different extended communities, and also local configuration. So we mix all this, and the end result is the route that we have to program in the FIB. So next slide, please. So this is what we are doing today. And is there a problem here? Next slide, please. I think it moved 2 slides. Previous one. Yeah. So basically here what we see is in the protocol machinery, we are unable to express more than one next hops in a route for the most part. And what we use as an endpoint or the encap or the forwarding action is not easily extensible. And even when we use add path, we are able to advertise multiple next hops, but we are not able to express the relationship between those next hops, whether we need to do active backup or ECMP or UCMP, what proportions. So these properties, they are important, or they can be useful if we want to use BGP as an API to the receiver's FIB. Basically, we want to say for IP routes or upstream allocated MPLS routes, if you want to say you install a route for this spec, and these are the next hops, either one leg or multiple legs, and what is the preference? Is it ECMP or ECMP N+1 backup? And what is the kind of load balancing we want to give percentage? And for each next hop, what is the capability? So if you want to express that kind of a thing in BGP, BGP becomes an API to the box's forwarding plane for any kind of a prefix in the NLRI. So because we don't have that, we cannot use BGP as an API there. And the inability to signal encap information uniformly for different address families. So for example, we use BGP free code for labeled address families, but for internet, because we're not able to signal any label or encap information directly for SAFI1 routes, we need IP or internet routes at an ASBR anywhere. But if we are able to signal a label for the SAFI1 routes also, then the core becomes completely lightweight, and the service routes are really confined to the edge. So that's like another advantage of having the NCAP or the next hops working uniformly across different SAFIs. Next slide, please. And also we have the inability to express multiple labels in a route, except for the proposal of repair label, which is carried as a separate extended community. And this is helpful in multi-home scenarios to avoid label oscillation. And then the semantics of a downstream allocated label is not known to the receiver. So this is like when labels are advertised in a BGP label family, the receiver does not know what is the properties of this label at the advertiser. Basically, whether this is, let's say for the EP use case, if we know that towards a peer we have more bandwidth than another peer, then the controller or the guy who is making the decision of EP can forward traffic towards the right label based on knowing what that label means at the advertiser. So there is some instances that this can be used if the receiver knows the semantics of the label. And then there is a problem that is slightly unrelated to next hops. It's at the route level. So what I've learned from some interactions with customer teams is that, so in option C domain, they want to have some kind of local preference like control, but they cannot use local preference because it's not allowed over AS boundaries. And this is, but still, this is like a single administratively controlled domain. So local preference, if you look at the design of it, it intends to be used within one domain, which is like one AS or a confederation system. But it does not consider option C domains as one domain because it has ASs. So if we have scoping information, scoping control to be able to propagate a local preference domain-wide, that works for option C domains also, and still have the restriction of it does not leak out of that option C domain, then that will be helpful. So these are the problems that I attempt to be solved by the multi-next hop attribute. So let's see how it works. Next slide, please. So in essence, this is an optional non-transitive attribute. We have been conservative in terms of how we restrict the scoping of the attribute. Initially, it was an optional transitive attribute, and it carried the next hop address of the advertiser so that we can do scope checking, just like what John was explaining in the previous presentation. But then, based on the discussions on the mailing list, I changed it to optional non-transitive. It's okay to be more conservative, so that it's absolutely not leaking out. And it is usage is negotiated with the new BGP capability, so that even if you have, so that it doesn't accidentally lead to eBGP peers, even if peer supports the capability, the attribute, but it's basically not willing to accept this. Then so it is negotiated using a capability. And it is actually a TLVS format, which is extensible for newer endpoint types, newer encapsulation types, and forwarding action types. And it can carry one or more next hop instructions. And it can be used as API for BGP-based API for tool of the receivers with. In the next slide, I'll explain the format of it. So this is the bird's eye view of the attribute itself. So it has a propagation scope checker. So this propagation scope checker is what controls the propagation of this attribute. And this is like similar to what Keyur was describing in the previous presentations. And here it is at the level of a MNH attribute. And if the conditions, if this propagation scope checkers functionality coincides with the scope checker that Keyur's draft has at the attribute level, it would be perfectly okay to lift this from the BGP multi-next hop attribute to a regular attribute level. I'll describe what this does in the next slide. So basically, MNH attribute has the propagation scope checker and a list of MNH TLVs. And each MNH TLV is of a certain type, and it has next hop forwarding information. So this next hop forwarding information is what actually describes a next hop, which is a container for a list of forwarding instructions. And a forwarding instruction TLV has a forwarding action and a forwarding argument associated with it. One or more forwarding arguments associated with this. So this forwarding action could be like forward, push, pop, and the forwarding arguments are where to do that and what kind of an encap to push, for example. Yeah, so next slide, please. So this is the propagation scope. So it's non-transitive, like we discussed. And it also carries advertising protocol next hop, which can be used to do sanity check on the MNH to see if it is valid. Basically, every speaker that resets the next hop to self, it removes this attribute. And when it is re-advertising the route with itself as a next hop or a new next hop, it adds this attribute based on the local intent, whether it wants to advertise multiple next hops on the new route when it is advertising it. So the advertising PNH should match the speaker which is advertising the MNH. It's just to sanity check to see whether it is getting advertised by the speaker which actually reset the next hop. And even amongst the speakers that understand the MNH, the advertisement is controlled by a propagation scope checker. So it has 3 flags, and by default, we consider that the MNH attribute is not advertised. and it is allowed to be advertised by turning on these flags. When we turn on the flag I, it is allowed to for advertisement to IBGP peers. And when you turn on the flag C, it is allowed to be advertised on config EBGP peers. And when we turn on E, it is allowed to advertise to EBGP peers, which are listed in the allowed AS list. So the allowed AS list is just a list of four octet AS numbers, which are in the same administrative control. So this is the option C domain. So basically the attribute, this particular PSC TLV, it contains everything that is required for restricting the scope of this attribute to a certain domain. And this enables the domain local preference to be used in option C domain scope. Basically, domain local preference is an MNH TLV of type of a certain type, and it just carries the local preference value. And because of having the scope checker, we are sure that it will not leak outside in the internet or outside of the current domain, and it can be used in lieu of the local preference. So just like we would use the local preference when we are receiving from an IBGP peer in the same domain, same AS domain. So here we can use the domain local preference when we are getting the route from the same inter-AS domain. Next slide, please. So these are the types of Reminisce TLV that is described, defined today. So the first thing is the primary forwarding next hop, primary forwarding path. So this is what you want to advertise, and this is like a next hop TLV with multiple next hop legs. And then you can also advertise a backup forwarding path. So this is to avoid label oscillation problem. So this is described in more detail in the draft. But briefly, when you have a multi-home scenario where in the MPLS network, where two PEs are, a router is multi-home to two PEs, and the PEs are doing next hop allocation mode, per next hop allocation mode. And they are also using each other as a backup path to repair traffic. So because they are doing per next hop allocation mode, whenever they receive a new label from the other PE, they will allocate a new label and advertise to the other PE. And this process repeats. And this can be solved only if we use either different allocation mode. Inside per next hop allocation mode, we have to be able to advertise a separate label for the backup forwarding path so that we can avoid the oscillation. Basically, the primary label allocated by PE1 should not depend on the primary label allocated by PE2. And the backup label advertised by a PE, it depends on only the primary path towards the CE or the other router. So this is the format of the TLVs is exactly same as the primary forwarding path, but it just says that this label has to be, or this encap information has to be used as a backup path when you are using that alternate path for repairing traffic. And then there is the downstream signaled label descriptor. So this is the label descriptor use case, where also the TLV information is the same, but it's just describing what is the semantics of the label being advertised by a downstream allocated speaker. And also the domain local preference that we just discussed. So these are the four types that are defined today. And unknown TLV types, a router which is propagating a MNH attribute, it is expected to propagate the unknown TLV types as well. And it error handling wise, it should not bounce the session or anything. It just skips and ignores processing it, but advertises it forward for any other speaker that understands that new TLV. Next slide, please. So this is the next hop forwarding information TLV, which actually describes the next hop, and it is present in the primary path or the forwarding path, the backup path, MNS TLVs, and it contains number of next hops, where each next hop leg element is described by a forwarding instruction TLV. Next slide, please. So the forwarding instruction TLV, it comprises of a forwarding action and one of more arguments. So this is where the extensibility comes in. So basically here we say these are the forwarding actions today that's possible. So if you think about it, in today's BGP protocol, the forwarding action that we imply is just forward. Basically, we have a route that's coming with the next hop, and we are just saying forward to that next hop. And when we allocate labels and advertise to others, we have different forwardings for those downstream allocated labels. It can be pop, swap, push, pop and lookup. So those things. But here we're just describing the different forwarding actions possible, so that even for upstream allocated labels, we can control the forwarding from an advertising node, or even for the, so it can work similarly for the different kind of payloads, for IP, for MPLS, for flow spec. And these are basically the known forwarding actions that are there today. But because it is a type, if any new forwarding action comes tomorrow, for example, replicate is not a forwarding action that we do in BGP today. Even for flow spec, it is defined, but probably not implemented. But if you think about it, if you want to do kind of a multicast replication forwarding using BGP, it's just a way you can express it. You just say replicate it, and you give the forwarding arguments, which will be the endpoints to whom you replicate it. Next slide, please. And the forwarding arguments TLV, they are basically the arguments that are required to complete the forwarding action. These can be, today they are just IPv4 address and IPv6 address. And in some flow spec cases, we also have the forwarding or context RD, that is a redirect to VRF kind of a case. And there are some cases where we also infer the next hop using the RD. There are some drafts or the allocated label. And the MPLS label is it's basically when there's an upstream allocated or global scope label, like you may in some forwarding paradigms like SR or MPLS namespaces, you can identify a node not only by an IPv4 address or IPv6 address, but also using an MPLS label. So these are the different kind of identifiers that you can use to identify the place where you're forwarding your traffic to. And even if you have a new kind of identifier tomorrow, we can just describe one. So today we have only IPv4 address and IPv6 address, which can be carried as next hop. So this forwarding argument TLV allows extensibility of that. Next slide, please. And so when we advertise next hop today, eBGP received routes, they are expected to be directly connected, and iBGP routes are expected to be multi-hop. That's just a general wisdom. And if you want to advertise a route and in that specify as an API whether you want a strict control for that next hop, so that it is only a single hop away, or whether you expect it to be multi-hop. So this proximity check constraint actually specifies or allows the advertiser to control that. When the S bit is set, it restricts the path to the single hop, so that the receiver confines, it doesn't use the next hop if it is multiple hops away. And if M bit is set, it expects it to be multi-hop. And if both are set, then M bit takes precedence. And if both are clear, then today's rules take over, where eBGP is single hop and iBGP is multi-hop. Or you can say, based on the configuration, eBGP multi-hop or whatever. So anyway, local configuration will trump any of these signaling, but it's giving ability to the advertiser what kind of proximity check he wants for the next hop endpoint being advertised in the route. And then you have other proximity constraints, path constraints like the transport class ID, or the load balancing factor. Basically, when you're doing load balancing, how much percentage of traffic you want to go for each of the next hop legs. Next slide, please. And we also have another forwarding argument TLV, which describes the payload encapsulation info. What kind of encapsulation we want to do towards that endpoint. It can be an MPLS label info, and inside this, basically this information, because it is carried on each next hop leg. So if you think about it today, we take the label from the prefix and the next hop from somewhere, and we combine them together and form the next hop. So here we are getting both of them in the same place. And the capabilities that we were discussing earlier, that is coming as a separate attribute that is also getting combined. So here the capabilities like ELC will be part of the MPLS label info, where it is it just appropriately scoped closer to what it describes. And SRMPLS label index info or the SRv6 seed info. And these are the encapsulation types that we know today, and newer ones may come in future. So it just accommodates all these different types that may come. And also there is like this endpoint attributes advertisement, which is like advertising what is the property of this next hop being advertised. And we could want to advertise multiple properties, like available bandwidth is one. Today it is advertised by a link bandwidth community. Again, it's just another community or attribute. So here we're just giving on a per next hop leg scope, we say what are the properties of this next hop we want to advertise. So this available bandwidth is used when we want to do UCMP. That is basically unequal cost load balancing. And when the path constraint of what is the balance percentage is required is there, then that is used. And if that is not there, then this one is used to implicitly derive on the UCMP percentage. Okay, you have a question?
Kaliraj, I'll wait for you to get done, then I can ask.
Okay, cool. Sure. And the error handling is also described in the draft. So basically, as a whole, it follows the attribute discard approach when some errors are encountered. So unless there is a length issue because of which we are not able to parse at all, then we will anyway bounce the session. But unknown TLVs are ignored gracefully with enough agnostic data. And we try to deal with errors gracefully by either ignoring the TLV or discarding the attribute. And for forwarding actions, if there are extraneous arguments, they are ignored. And if the minimum required arguments are not available, again, the forwarding instruction TLV, that's the next hop leg, is ignored. If num next hops in the NFI TLV, basically because attribute is flexible, so it also has the ability to advertise number of next hops that a receiver may not be able to accept. So in that case, he can just ignore the MNS TLV. That is the currently described approach. We could also say that you consume the number of next hops that you can, and log diagnostic data to say that others have not been consumed. So currently it is the attribute discard approach, which is the more conservative approach. So there are more details about error handling in section 6 of the draft. I think I'm done with that session. Next slide, please. Yeah. So that was a brief about the attribute. So we just wanted to put it out in the working group. This attribute has been, the draft has been there for a while, but because of the renewed interest, I just spent more time and normalized the format and layout a little more so that we can start taking input from the working group. Yes, Kiyur.
Yeah, so I kind of like this. And one of the things I wanted to ask you was, you have defined this as an optional transitive attribute which can carry label information. There is a tunnel attribute, and then there is a BGP NLRI also that carries the label. So in some ways, if you can somehow work with what is existing as an attribute, that would be super good. So that was a comment. And then the question I have is, you're carrying label is very interesting, so I'll stick to label for a sec. You're carrying a label with next hop. Typically, one use case I think of when I look at this proposal is layer 3 VPNs that recurses over BGP LU, which recurses over IGPs, right? And if you are carrying a label to a next hop, does it mean I can short circuit BGP LU completely?
Yeah, so so the first thing, it is not an optional transitive, it's optional non-transitive. Just a clarification
there. My bad. Yeah, it's an optional non-transitive, my bad.
And about which address families it is carried on, yes, you're right. It can be carried on LU also. It can be carried with unicast also. And when you carry it with unicast, because you can specify a label for a unicast SAFI, you can not use LU, and you can just specify a label with this attribute for unicast also. That's one application.
Yes, and though in case of a layer 3 VPNs, if I carry this on a VPN SAFI with an next hop and a label, then technically I don't need to turn on BGP label unicast 3107 address family, which carries the loopback addresses typically today, right?
Yes.
Because, right?
So there, what we are talking about is collapsing the service layer and the transport layer, right?
Exactly,
So,
exactly.
so basically, it helps for other reasons to keep the transport layer and service layer separate, where you
If
have a transport family which carries only the loopbacks, and the service family which carries the services behind those loopbacks.
Correct. Correct. If specifically if we are trying to do interesting things like coloring the routes and other things, but if it's just getting a vanilla loopback addresses, then I think you can pretty much zap the entire SAFI.
Yeah, right.
Cool. Thank you.
So yeah, I think it has been kind of overwhelming because I've tried to go through the all the different type of things that have been done with Nexthops in BGP so far, and put this in a format which is like not too involved, but still it is extensible and flexible. So it's a lot of data for you to consume. So any comments offline on the list is welcome.
Yeah, I'll send you my comments offline. I like it, so but I do have some comments, so I'll reach out to you. Thank you.
Sure, thanks.
Other comments from folks? This is a lot to drink at once, but any comments or questions? Okay, that is the end of our presentations. Please reach out to Kaliraj. We will probably continue discussing next top at ITF, but our ITF time is usually limited. So with that, I'll ask Jeff or Kay if you have anything else to mention to the working group.
Nothing further from me. I agree that the multi-next top is very complicated in terms of what it's trying to do. I think that, the immediate value for it is Kaliraj has done a nice job of gathering the sets of things that next tops are used for, and we can take the conversation on from there.
And I agree with Jeff's comments. Kay, any comment?
All good from my end. Thank you.
To
Thank
a
you, everyone.
good day, and we'll see you at ITF 115, virtually or physically. Take care. Bye-bye.
Bye.